Hey guys, it's Coach Dan here, and this is going to be a continuation a part 2 from the original FTC Drivetrain assembly video. So that was part 1. In this video, we're going to be continuing on and making the drive rails. So we're going to be using the motors that we created and that we assembled to create a drive rail. And with that drive rail, we'll just copy paste it over to create 2 drive rails by the end of this video. So if you haven't already watched that video, make sure you do, because it's quite important, and we're just going to be continuing right on. So as you can see, I've got my screen open here, and continuing on, we have 2 motors that we created. And if we go back to the documentation that we were following, this is exactly what we needed to create. So this documentation said 4. By the end of this video, you'll realize why we only need 2. So we'll continue on. This was the ultraplanetary gearbox. That was video 1. Now we're going to be moving on to the drive rail assembly. So we'll move on to the drive rail assembly. And as you can see, we'll briefly explain what we need to do within this documentation, or within this sub-assembly. So within this assembly, what we need to do is first we need to combine pulleys together. So with those pulleys, we need to make sure that we have 2 of them. Once again, there's a 4 here. It'll make sense why we only need 2 later on. So we need to make 2 pulleys. After we make the pulleys, we then need to use our motors and connect it to C channel. So once we connect it to C channel, we'll connect the end caps to that C channel. After we put the end caps in, we have to connect a lot of different hex shafts into the motors. We'll put the pulleys onto those motors. We'll connect everything up together with a belt, as you can see here, and then we'll close the drive rail up together. So this is going to be kind of a fairly long video. As you can see, there's a lot that's going on, and unlike the previous video where we had our motor previously made for us, everything has to be with individual parts and then connecting those parts together. And then using those parts with more individual parts and putting them together. So unlike the previous video, this is going to be a little bit more involved and a little bit longer. So we may as well just get started. So the first thing we need to do is to take our pulleys. So it's always good if you want to open up your object into a new tab to see what you're getting. So for this object, it's just a regular pulley, but that's only 1/2 of them. So we need to import these 2 pulleys and then connect those 2 together. So the rev number is going to be 451823. So we'll move to SOLIDWORKS, and just like last video, we completed these 2. You don't have to do things like directly in order, so we can just kind of like yeet these to the side. So once we've got a bit more space, another thing you can do is just to close this left hand tab, because we don't really need it until we look at it. So you can just open it up using this button and then close it again. So we have a lot more space to work in now. So we can now go ahead and insert our pulley. So the thing about the pulley is, if we go back to our documentation, it says here in the documentation we need to import 451823, but then when you go to the actual product page, it's got that the whole pulley, the number is actually 411669, and we just need the pulley, not the insert. So we have 2 different numbers here, but we'll just analyze to see what's in our library, and then we'll just trial and error to see which one's the correct one. So we'll go to our library, insert component, and generally speaking, you should always use the number it says on the product page, because that should be the correct one. Sometimes they'll get it wrong on the actual documentation. So we'll go to all rev parts, and we know we're looking for 451823. So we'll go down, and if you see here, all of the 45s, 1823 isn't here, which means this documentation number, it was just a mistake. So we'll go back to here, and you can see how here it says 411669, just the pulley. So we'll go 411669, go back to SolidWorks, find 1669, and we can see that it is right there. And we'll insert this little part. So we'll insert the part. It's quite small, but we'll just zoom in on it, and we can see we have our part here. And it's just one end of the pulley. So it's not both, it's just one. So we can move this around a little bit to get a better view of it. As you can see, we now need 2 of these, right? Because we need to combine 2 together. So we'll go back to the documentation, and you'll see you need to take 2 and place them together. They're exactly the same, so we can just copy paste it. So we'll copy, Control C, Control V. And one thing you need to do is you need to make sure that the object is kind of in the orientation where you want to make them. So we'll have to just move this around. So we'll save the document, rebuild and save. It's always good to make sure you're saving your documents consistently, because you never know when it can crash. If you've done robotics before, that can be quite a devastating experience. So like I said, we now need to move this whole kind of object around to make sure that these pulleys are facing each other in the correct orientation. So all I did was I clicked one edge, and now I'm using my right button on the cursor, and I'll just move it around a little bit, and I'll just place it like so. So as you can see, now we've got them facing the correct direction, and now we can start mating them. So for mating them, we need to make sure that this kind of like extruded piece here is in this gap here. So what that means is the circle next to it. So I'll click this circle. That circle needs to be directly mated with this circle here. So the circle with the opposite end kind of needs to be mated. So I'll shift, press the semicircle, let go, and concentric mate it. And you can see now that it's moved that circle to this side. Now this isn't really a big deal because all it means is that we just need to get the correct one for the other side. Now that we've done that mate, we now need to find another circle that links up and connects the other two. So if you ever forget what mate you need, you can just open this left hand tab and go to history. And so the mate that we just did is we connected this this kind of outer circle there to this inner circle there. So the easiest way to find the corresponding one is to just look at the opposite. So the opposite of this circle here is that one in there, and the opposite of this circle here is the one on the left hand side just there. So very easily what we can do is we can look at this circle and we can line up one side. So we'll take this side, press shift, and this is where you have to use your memory to kind of remember where the other circle was. If you remember, it was just this one here. Shift, let go of shift, and concentric mate those two. So it's very important to make sure after you concentric mate one circle, that can be any two random circles, but the other circles have to be the opposite ones, or the ones that line up correctly. So we'll move this around and we'll make sure that our circle is lined up. And as you can see, our circle now, if we try and move it side to side, it actually won't move. The reason being, like, the whole thing will move because our two circles are perfectly lined up, but they can still move in and out. So if I ever try to move it kind of like this way, you can see my circle still moves. I just have to connect them like so. So to do that, all I need to do is do the satisfying coincident mate, which is this face here. It doesn't matter which face, it's just a face on the outside that kind of shift coincident mate to a face on the inside. So we'll do that. And as you can see, our pulleys are now moved together and they're perfectly concentric mated. We can go back to our documentation to make sure it's correct. As you can see, it looks exactly like we have it in SOLIDWORKS. So now we need two of these. So all we have to do is copy it, Control C, and paste it, Control V. So my two pulleys are now pasted. Once again, it can kind of fly anywhere. Like, we have infinite space in SOLIDWORKS. So just make sure you have your whole object kind of selected, and we can now move them closer together. So we'll select the whole thing and we'll just move the whole thing kind of upwards. You can use the blue dot and just move the whole thing like so. So now we have our two pulleys and we also have our two motors. We'll move on to the documentation and we'll see that the next thing we need to do is actually take a certain length of C channel and then connect our motors onto that C channel. So which C channel is it? So you'll see that it's 45 by 15, 408 millimeters. So we'll go up to our parts list here, and it's this rev number here. So 411762 is this C channel. So we'll go back to SOLIDWORKS and we'll import 411762. So all files, 411762. So I've got my part just here. Open that part. Let it open. Because it's an individual part, it shouldn't take too long. And because we're connecting it to the motor, we'll kind of try and move it in some way close to the motor. So we'll drop it in and we'll let it load. Once again, as you add more parts, you'll get kind of these resource monitor requests and warnings. It kind of is a big deal, but then you can just keep going until it fails, essentially. So what we'll do is we'll close this here. And now we can work to connect our two motors to this C channel. So what we'll do, just for the sake of getting everything in line, we'll move this here and we'll move this around. And we can see we're kind of getting closer to vertical. Okay, we'll do it like that. And then we can move this side as well. This is kind of a long process, but you have time. You can just work out exactly how this needs to be. Right, we'll rotate it like so, and we're a lot closer now. And we'll just move this whole thing up. So once again, to rotate, click aside and use the right button. To just move, use the left button. Okay, so now our motors are kind of close. We'll just move it to the correct spots. So we have to connect these to a certain we'll use the bracket to connect it to a hole. So we'll move them anywhere kind of in. So now this is kind of an angle, but we'll just coincidentally make things that'll bring it together. Let's go back to our documentation. And we'll zoom in here because things get a little bit dicey and a little bit hard to see. So the first thing you have to see is that this whole motor, it's going to be connected to the fourth hole from the end. So if I zoom into the motor, you can see that there's a little circle. That's basically the base of the motor. And we now need to use this circle and connect it to the fourth hole. So we'll take that circle. It's going to be a semicircle because that's just how it is, the parts. And then we'll shift, take this circle, and we'll concentric mate those two circles. And as you can see, it kind of did a fairly decent job for us actually. It's just that our whole motor is at an angle, but the actual circle is lined up. So if I let go here, you can see that the motor is perfectly lined up with the circle. The next thing we have to do is basically make this part, this top part, flush with this part here. So now what we have to do is we have to make this whole bracket level with the C channel. So we'll take this and we'll press shift and we'll take the C channel top. It's just going to take a while to load. Let it go, and we'll make them parallel. So you can see now it's a lot nicer. Our motor, the top of the motor is perfectly level or in line with the top of the C channel. So if we now look at this from this angle, we can see everything is lined up. The only thing is our motor isn't connected. So quite simply, all we have to do is now coincident mate these edges. So this edge here needs to be kind of slapped on to the face. So we'll take the face, we'll make sure it's all ready to go, shift, let go of shift, and we'll coincident mate them. So just play around with it and make sure you kind of have the correct mates going on. Once you mate everything together correctly, it'll take a couple of tries to get it correct, but you can see I've got my motor now perfectly mated onto my C channel. The holes are lined up, everything is looking okay. So now that that motor has been mated to the C channel, we just have to do the exact same thing to the other motor. So we'll just zoom out and we'll grab the other motor. I think it's flying on the edge here, so we'll just align it in a way that is kind of resembling how we want to mate them. So the only difference with this motor is that it's going to be connected to a different hole along the C channel. So if we look at the first motor, this was 4 holes across, so 1, 2, 3, 4. If we go back to our documentation and we zoom in, we can see that this motor here, you can count it yourself, but it's essentially going to be 13 holes away from that first distance here. So this distance, 13 holes away from there. So we'll just go back to the SOLIDWORKS software and we'll count 13 holes from the edge. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this is the 13th semicircle here. So what we'll do is we'll zoom in and we'll select the inside just there. Now we'll go back to our motor, and this time we'll get a pretty clear view of where we want to concentric mate our motor because it's quite far away, but that doesn't matter because once we concentric mate them, this whole motor will move across. So remember to press shift, press the other semicircle, let go of shift, and we'll concentric mate those two. So it's flown right across. The next thing we have to do is parallel mate them. So we can still kind of move this whole thing at an angle. So now you can see it's not level with the C channel. So we can take the top face, press shift, and take the top face of the C channel, let go of shift, and we'll just parallel mate them. So now everything is level with the C channel, both motors are. I'll just zoom out a bit to give that a clear view. And now the last thing we have to do is simply coincident mate the face of the bracket and the face of the C channel. So we'll zoom out, turn it around, and if I can press shift, press the C channel, let go of shift, and we'll coincident mate those two things. And that's pretty much it. So both motors have now been connected to the C channel exactly. If I try and move the motor, it's not going to move, it'll move the whole C channel. Same with this motor. So both of these motors have been perfectly defined onto the C channel exactly how we need it. Okay, so now that we've completed the second motor, we can now move on to the next task that we have to do. So I'll open up the documentation, and as you can see, we basically have to now insert the U cap or the U channel end caps. So that's this piece right here, and we have to insert it into both ends, just like so. So we'll get the rev number for the U channel end cap. So we'll scroll up here, and the U channel end cap 411687. So we'll go back to SOLIDWORKS and we'll open up 411687. So we'll go to assembly, insert, wait for it to load, we'll go back to SOLIDWORKS parts, 411687, all files, scroll down, and it is just there. So we'll let it open, and as we can see, there's a nice little U cap here. So something that you can do if you're not really bothered kind of moving things around manually, you can use this X, Y, and Z to flip things around 90 degrees. So if we use the Z, we can see that it kind of flips along this way. So if we put it here, and now we can, what we can do is we can flip it along the Y. That doesn't really do much, and I flip it along the X. Now it kind of helps us. So we can use a combination of these to kind of get it in the right direction. So now it's actually facing the correct direction. So the ends are facing the outside. So now that I've inserted my component, I can now go ahead and mate it. Something you recognize is that the shading's just got a little bit different. So as you increase the components within SOLIDWORKS, just to kind of manage all the settings, it may change some of the display, but that's not really a big deal. So the first thing I'll do is I'll mate the circles. So if we can make two circles, we can see we have one middle circle here. That's probably going to be a pretty good starting point to make things. So we'll click the circle here, just the circle, and then we'll press shift and we'll click this outer circle here, let go of shift, and we can concentric mate those two. Now this is kind of looking pretty good. We can now make another set of circles. So what we'll do is we'll make this top kind of, this is not really a circle, it's two semicircles with like a line in between, but we'll try and make them anyway. So we'll try this top and that side, and we'll concentric mate them. And as you can see, quite nicely, this whole thing moved in. And the last thing we need to do is just coincident mate the faces. So shift and let's coincident mate them. So as we can see, the U channel end cap very nicely just slid into the C channel. So I'll copy paste this piece once more, just because we need another version of the U channel end cap. And this time I'll throw it on the other end. So this time, because I copy pasted it, I'll have to manually kind of rotate things. So I'll zoom out, put it here, and the end needs to be facing the other way. So this face here needs to be facing the outside. So I'll just click aside and I'll just rotate it like so, just to get it like that. I'll then turn this whole thing around. Once again, I'll get the inside of this circle. You can use kind of any of the two circles along the path you want to. I'm just using the middle one because that's kind of the most direct one. Press shift, press the circle, and I'll concentric mate them. That will fly to the other end. And now I'll do the top circle again. In fact, I'll try to do the bottom circle just to illustrate kind of how you can use different ones. If you use this side, you'll notice that there's the adjoining circle is here, whereas if you use the end, the adjoining circle is here. So it's kind of up to you how you want to concentric mate them, because you have a few options. As long as everything is fully defined and you kind of do 3 mates, that's perfectly okay. And the last one in this scenario is coincident mating these two, and I'll do that quite easily, just like so. So now once again, our U-channel end caps are fully defined. So if I ever try to move the U-channel, it's going to move the whole drivetrain. So that's really good. So now we'll move on to the next part of the documentation. So if we scroll all the way down, we completed the U-channel end caps, which were right here. So we've done those two. And now we need to add a bunch of hex shafts. So we need to add a 75mm one to the inside of the first motor, and then a 90mm one to the second motor, and the outside just along the fourth or third hole. So we'll decide that when we get to it. But essentially we need to now put 3 hex shafts along the C-channel. So the lengths, if you want to follow the documentation step by step, you can. I'm going to vary them just a little bit. So the one I put on the inside motor, I'm going to leave it as 90 degrees. But the one I put on the outside, so these two here, I'm going to make them 135mm. So they have another piece. If I just scroll up, I'll find the 90mm one. So the 90mm hex shaft, if I scroll out, it's just there. So I'll open this in a new tab. So Rev Robotics have this 90mm hex shaft, which is what we'll use for the inside motor. And then for the outside motor, what we'll do is I'll just copy paste this and I'll show you which one I'm going to use. So I'll change that, and I'll change the 195, oh it's come up, so 135. So we'll use the 135mm one for the 2 hex shafts on the outside. The reason why I'm changing it is because I'm going to use a different set of wheels to what they're saying in the drivetrain, in the documentation. So our team, we've made a few custom choices with our drivetrain. So just to adjust for this, we have to change a few little things. So for the purpose of this video, I'm going to use a different piece on the outside. But that's okay, we can go back to our documentation. So we'll insert the 90mm one first. So the rev number is 411348. So we'll go back to documentation and we'll insert component. So we'll go to all files, 411348. So we'll go down and we'll select 411348 and we'll open that. Let it load. Once again, actually the way it's come up is pretty nice. It's already kind of in the correct direction, and like we said, this is going to be for the middle. So I'll just leave it there. And now this part can get a little bit tricky. Essentially now we need to insert this kind of into the hole exactly like that. So the way we do this, it's not too hard once you get the idea. You can try and mate it for yourself and see which mates work. I'll just show you now. So it took me a couple of tries to actually get this correct. What I'm going to do is I'm going to take one face of the hex shaft, press shift, and take one face of the inside of the motor. And I'm going to coincident mate those two. So this will now fly up. So once you made it like so, you can see that that side kind of stays along the same path, but this can now move diagonally up and down. So all we have to do to fix that is now coincident mate another set of faces, and I just like to choose the next one along the path. So the next one along here is the top one, and then we'll line it up with the upper rectangular piece and we'll coincident mate those there. And so now if we try and move this around, I'll zoom out a bit and I'll try and move this in and out. As you can see, the whole thing kind of looks pretty well mated. The last thing we have to do though is now mate the faces. So this whole thing, it's not supposed to be kind of that far in and out. So I'll just push this out and we can now mate the inside of the motor with the end of the hex shaft. So I'll zoom around and I'll find the circle on the inside, press shift, this time get the face of the circle, and we'll coincident mate them. So in that scenario, we needed 3 coincident mates to perfectly mate the hex shaft into the motor, and now if I try to move the hex shaft, the whole motor doesn't move. So now I'm going to do the exact same thing for the other motor. So because we're not using a 90mm one, we're going to be using a 135mm one. The rev number is this now, so 1349. So I'll go back to SOLIDWORKS and now insert 1349, all files, 411349, just that one there. Insert it. Now this time it's actually come up kind of in the wrong direction, so I'll just play around with them to find the correct orientation. So kind of like that. I'm kind of good with that. So you can just trial and error, press X, press Y, press Z, and if you press it a few times, it'll just go back to the original direction that you had it. So if you make a mistake, just keep pressing it and you'll get to the correct kind of system you need. So once again, for this, it's the exact same process. 3 different coincident mates. So firstly, I'll do the upper one this time. So I'll take that and I'll line it up with the upper face of the motor. Coincident mate them two. Perfect. So now, if I try and move this around, it still kind of moves in and out this way and that way. So now what I'll do is I'll coincident mate the edge. So the next face on the left is that one. You can try the left or the right, it doesn't really matter. And I'll take that face there and I'll coincident mate them. Perfect. So now the motor is lined up with the hex shaft. It can just move in and out. So what I'll do is I'll zoom out and see, you can see how it's very deep into the motor. It's not supposed to be that way. So we can just move this whole kind of hex shaft outwards. All we need to do now is just coincident mate the end. So I'll move it out and I'll get the inside of the motor, the face this time, not the semicircle. I'll turn this around to get a clear view of the end of the hex shaft. I haven't really given myself a lot of room to work with, but I can just zoom in, press shift, and I've got the end of the hex shaft, and I'll coincident mate those two there. Perfect. Okay, so now if I zoom out, I now have my 2 hex shafts perfectly mated into the C channel there. And lastly, what we need to do is do the same thing, however, on the other side. So you might be asking, what's the purpose of having 3 hex shafts, right? Because the wheels are going to connect to the hex shafts. And we only have 2 wheels on either side. So why do we need 3 hex shafts? Well, if we scroll down, we'll see, so we've completed these 2. So we've put this one in and we've put that one in. Now it's asking us to put a third one. It says 90mm, but we'll use 135. And it's got an extra additional piece here that we have to insert first. So the reason why we're doing this, if we scroll down all the way, our pulleys will go on the second motor and the end. And then after that, we're going to have a belt connecting those 2 hex shafts. So when this motor turns, the last hex shaft will also turn. So the benefit of this is that our motors, if we look at the final, our motors are going to be kind of back, which leaves space at the front of the drive rail for intakes and for additional mechanisms. So by using a belt, it's not really that advanced, but it's a very nice design choice that you can do on your drivetrain, and we'll do it as well within SOLIDWORKS. So as I mentioned, the first thing we're going to have to do is insert this hex block here. So I'll go up to the part where it says it. We kind of did things a little bit out of order, but that's fine. So we now need to insert this hex block. So we'll grab a hex bearing block from the documentation. So hex bearing block is 1683. So we'll go back to SOLIDWORKS and we'll insert all files 411683. That's just this one here. We'll open that one. And now once again, it's kind of not really in the direction where we want it. So we want it facing kind of parallel to the drive rail. So we'll turn this around. That one didn't really do much. So the X should do a pretty decent job. We'll drop it in. And now we can see that we have our hex bearing block ready to go. So it's important to work out which distance we want it. So now we're working from the other end. I'll go back to the documentation and we'll see where we connected the hex bearing block. If we zoom in here, it's actually the first, second, third, fourth hole. So it's symmetrical to the motor. So we'll find the 4th hole from the other end now. So 1, 2, 3, 4. This hole here is where we want our hex bearing block to go. So we have a bunch of circles here that can help us connect it. So what I'll do is I'll first concentric mate the circle on the 4th hole, and I'll just choose any one of these circles. Once again, concentric mating just takes 2 of the insides of the circle. So this circle on the outside and this circle on the inside, they share the same point. So it doesn't really matter which circle we go for. So we'll just hit the circle, press shift, let go of shift, and we'll now coincident mate them. So now that's looking pretty good. The next thing we have to do is we have a couple of choices here. I might as well just parallel mate kind of this part here and the inside of our C channel. So they need to be flush with each other, which means I'll just parallel mate them. So that turns around very nicely. And as you can see, we now have it lined up perfectly on the 4th hole, and we just need to coincident mate the edges. So I'll click the face and I'll click the C channel face, shift, let go, and I'll coincident mate those there just like so. So now that we've got the hex bearing block in, it's essentially like the motor now. So we can just complete the third 135mm hex shaft by inserting it. So 1349 is this one. Go back to the SOLIDWORKS software, insert component, all files. By this point you'll get pretty fast at this. 411349. Scroll up a little bit and open. So once again, it's not in the correct direction. We'll just move things around a little bit, try different combinations, and there we go. That's pretty good. So this time it's kind of come out a little bit. I'll just take the top face and I won't muck around. I'll just quickly mate it to the inside of the bearing block. Coincident mate them there. Now the top, we can see we can select the top and we can select this top here. Shift, coincident mate them there. And finally, to get the direction inside and outside, this time it's not as clear exactly what we need to do, right? Because before we had the inside of the motor to work with, now we don't know where this has to be level up to. And in fact, this is kind of your choice, right? When you're inserting this hex shaft, you can kind of stop it at any point. But what we'll do is we'll stop it kind of at the face of the bearing block, because that's how the actual mechanism works. So I'll just coincident mate them there. So by coincident mating them, it kind of puts them to the same level. So now this piece is perfectly flush and parallel to the hex bearing block, which is exactly how it needs to be. Okay, so now we'll move on to the next step. And this is where I'm probably going to skip over things a little bit. As you can see, our drive rail is getting there, but it's only halfway done. And the next few steps, it's not like they're not necessary, but it's essentially just spaces. So these spaces, it's going to take us a long while to insert 3 different spaces onto one. And then you have to do the same thing for the other end. So it's kind of just placing the spaces. And then in between the spaces, we're going to put the pulleys. So what we'll do, just for demonstration, we'll just put the pulleys in. We won't put any of the spaces. So in reality, if you're doing this kind of for your team, you will do things exactly perfectly. But we'll just do, just for the sake of the video and keeping it short, because it's already gotten pretty long, we'll just put the pulleys in because they're already made. After we put the pulleys in, it's just more spaces once again. Nothing too difficult. You just made it exactly how you made it the hex shaft. After that, we have to put the belt on. However, there's a little problem we'll come to there. And then we'll just close the whole drive rail up after that. So once again, we're going to skip over a few parts here, but the next thing we'll do is put the pulleys on. So we'll grab our pulleys. They were kind of flying around. The second one is over here. So I'll highlight it and I'll just try and move it in closer. And our pulleys, they're actually going to be on the end. So we'll push one all the way to the end, just there. And we'll push one on the inside motor. Just there. And now mating this, it's going to be exactly the same as mating the hex shaft. It's kind of not really directed properly, so I'll just try to rotate it slightly. And you'll see we have the same kind of hexagonal pattern. So what we'll do is we'll just mate it to this side because that's where it goes. The first side along the hexagonal pattern, it doesn't really matter how you mate them. But then the second side is quite important. So now that kind of looks like it did nothing, right? Because it didn't really help our cause. So what I'll do is I'll go back to history. So if I go back to history, the last thing we did was coincident mate these two. So it'll highlight exactly what we did. As you can see, it coincident mated the inside face there and the top face there. So what we'll do is just along the next one, if you're moving kind of left, you have to move left or right the same way. So I'll just move this in a bit closer just to give us a better view of what our next mate needs to be. So I'll move it like so. And now if we click the coincident mate again, it'll come up to exactly what we did. So we just coincident mated those two. So now we'll just coincident mate the next two along. So the next two along are going to be this one here. And if I just move around a little bit, it's going to be this one here. So I'll press shift, let go of shift, and I'll coincident mate those two just there. So now the whole thing kind of rotates around. and now it's perfectly coincident mated. So once again, when you're coincident mating things onto a hex shaft, choose one side, it doesn't really matter, but then the next side you choose, it has to be the one that's over, corresponding for both of them. And what I'll do now is I'll just move this in ever so slightly along to this face here. So we'll have it touch the C channel. In reality, you would have spaces there, so you wouldn't have it in this system here. But you can see that the drive rail is kind of perfectly designed to have this supporter on the inside. So we'll take the other pulley and we'll do the same thing to the other side. So we'll move it in closer and we'll just shift it around a little bit to give us a clearer view when we're mating. So we'll just move it like so. And now we'll take one side. So I'll do the same kind of top. So that's the top of that one, and the top of this one, or like the upper lip, is just here. Shift, and we'll coincident mate those. Perfect. We'll now move aside, and this can get a little bit tricky, but once again, we did the top, so the next one along the line will be this one here, and hopefully the next one along the line will be this one just there. So shift, press it, and we'll try coincident mating them. So that time, those actually were the correct two corresponding ones, and this pop-up comes up. So what it means by successfully, not successfully creating the mate, that means that we've made a mistake. So do not break your assembly, otherwise you'll have problems later on. So press cancel, and we'll try to find where our mistake was. So we'll go back to our history, and we'll press the coincident mate. So we mated these two along the line. So we now need to find the next one. So I think my mistake was I clicked the wrong face. So we'll try that again. This time we'll select this face here. And now we'll select, go along the line. Then we'll select this face here. And we'll try coincident mate them. And now that time it did work, which means that my mistake was I just pressed the wrong face. So I'll press this now, and now that they're lined up, I can now make it flush with the shaft. Perfect. So now our two kind of pulleys, they are on our shaft. Now the next thing you need to do is put a belt on it. So if we go here, there's more spaces which we'll skip over, but we now need to place a belt onto the drive rail. So this belt, they have kind of like an image of it here. And if we go back up to our pitch belt and find the rev number for it, you'll see that there's a problem here, like I alluded to just before. So we'll find our pitch belt. It's just here. I'll open this in a new tab. So I'll close the hex shaft now that we're done with them. If we go down to the bottom, there's no CAD file for them. And the reason for this is because a pitch belt, it's essentially got some elasticity to it, which means it's quite difficult to create a CAD file to it. It's not impossible, but it's not really, Rev haven't supplied a CAD file or a part for it. Now the great thing is it doesn't really matter, because once we close up our design, the pitch belt has nothing to do with any future design. It's just going to be a belt connecting these two pulleys, and we're not going to build or connect anything inside the drive rails once we're done with them. So what we can do is we can just skip over that part too. So if they haven't supplied us a part number for it, or any CAD file, we can just move over. And now what we'll do is we'll connect this drive rail, and we'll connect it to the other C channel, and we'll close up the whole drive rail like so. And this is going to be the last thing we need to do. So I'll just get the correct number, because we'll insert the C channel. So it's going to be a 408mm C channel. We'll go up to here. That's going to be 411762. So we'll go down to here, insert component, and what we'll do, all files, and we'll get 411762, press that, and we have a C channel. And now we'll just rotate this along into the correct direction we want, so like that. In fact, I think that's pretty good. We'll try along the X. Yeah, that's kind of reasonable. We'll move this around one more time to get it like so. So we'll just move it around exactly how we need it later on. Okay, so now that I've inserted my C channel, I can now work to connect it exactly the same way I kind of connected my U channel end cap. So you can see there's a nice little circle here that lines up perfectly with the circle on the C channel. So I'll zoom out of there and I'll zoom in, shift, try to get the semicircle. Oops, that did not work. Let's do that again. So I'll do that and I'll do it again, shift, and now I will concentric make those two things. So it's kind of looking like it's a bit wonky. I'll close this just for the sake of clarity. And now I'll do the same kind of concentric make up top. So I will shift, press this, shift, press the other one, and I'll now concentric make those two. And now that really satisfyingly turns my object around. And now, as you can see, you only need to do one side, right? Because the other side, this is automatic. The last thing we need to do is now just coincident mate. So now I'll press that, shift, press that, and I will now coincident mate those two perfectly like so. And that is it. That's our full drive rail complete. So congratulations if you've gotten up to this step. There's a lot going on here. As you can see, we have the motors, we have the pulleys, we have the hex shafts, U-joint end cap, and then closing it all up. So it's quite an extensive process. But now the last thing we'll do is, as you can see, if we scroll all the way down, we have something similar to this. We don't have the belt and we don't have the spacers, but that's okay. Once again, if you're in a competition setting and your team expects you to kind of produce a CAD model, do everything exactly as you see it. But in our scenario, just for teaching and to keep this video nice and short, although it's not very short, we'll just keep it simple. We now need to create two of these drive rail assemblies. So what we'll do is quite simply Control C. Now, if you're using a older laptop like I am, this is going to be a heavy process. There are probably like 70, 80, maybe 100 parts already in our assembly. If we double it, it's going to increase it to 200. So we'll see what happens. Oh, it did a pretty good job. We'll move this around like so. Yeah, that worked out pretty well actually. I'm not too fussed by that. So if you have an older laptop, that may be the step where your laptop breaks. Not your laptop, but the software breaks. In that scenario, you really can't do much. You learn how to use SOLIDWORKS. You just need the correct resource to use it. So now that we have our two drive rail assemblies, in the next video what we'll be doing is we'll be kind of assembling this in a final assembly kind of scenario where we'll be attaching the wheels and connecting these two drive rails. So if you can't really see the end goal, I suggest you go to this final assembly. I'll explain the whole thing in the next video. This is part 2, so the next video will be the final part 3 where we'll complete the whole drivetrain. But we'll kind of see in this documentation the end goal. So we'll connect our two drive rails with a C channel along with 2 extra extrusions, and then finally we'll just slap on the 4 wheels in the right direction, and we now have our mechanism drive kit complete by the end of next video. So that's it for this video. Hopefully you guys are enjoying the series, and I'll see you guys in the next video.